This is a lesson on solutions and electrolytes. Ionic compounds dissolve in water by having the cation, positive ion, being surrounded by the negative end of the water. Remember, water is a V-shaped thing with the oxygen being the negative part, which is in the middle. And the anion is being surrounded by the positive end of the water. Remember, the total force of the water on the ion is greater than the ion with the other ion. It will dissolve. This is called hydration. Where water surrounds the ions, exposing the next layer. Hydration is just another word for dissolving. The solute, or the solid does not disappear, it doesn't go away, it's still there. It's just in such a finely divided particles you cannot see it. Electrolyte is a solution that will conduct electricity. And it will conduct electricity because it has moving ions. So if it's not an ionic compound, it's not an electrolyte. If it's not dissolved or hydrated, it's not going to be conducting electricity. So you got to have free moving ions that conduct electricity. You have strong electrolytes. Strong electrolytes completely ionize or fall apart 100%, like strong acids and strong bases, like we talked about before. So strong electrolytes 100% fall apart. Strong acids and strong bases are those. There are weak electrolytes. Weak electrolytes only partially fall apart. And we are familiar with these in the form of weak acids and bases. And then we have non-electrolytes. Non-electrolytes do not conduct electricity because there are no ions present. These are made up of polar molecules. Pure water, pure distilled water is a non-electrolyte, but don't trust it because there's always impurities and you don't want to risk hurting yourself. The nutritional electrolytes that you see on sports drinks containers, these are in the ion form only. The FDA mandates that they are in the ion form only. In chemistry, we can talk about the solid being electrolyte if it was dissolved, but in nutritionally speaking, if it's electrolyte nutritionally, it has to be in the ion form. A couple of terms on solutions. The major component, thing that is doing the dissolving, is the solvent. The minor component, you can't spell component. The minor component or components are the solute. In salt water, Water is the solvent, and the salt is the solute. Sometimes we call water the universal. Universal solvent because it's readily available. 3 reasons: it's readily available, it does a pretty good job in dissolving a wide range of things, and it is fairly cheap. You can have degrees of being dissolved. You can have saturated solutions. A saturated solution holds all the solute that it can. Unsaturated holds less than the maximum. And then you have something called supersaturated, which holds more than it should. You do this by you heat up the liquid, the water, and you dissolve the substance in there and cool it down slowly. And if the conditions are right, it won't form a solid until you irritate it, add some more, or scratch the surface or something like that. Sweet tea and regular tea. You can put a lot of sugar in regular tea, but it will never be as sweet as sweet tea. The sweet tea, the sugar is added as it is very warm, and therefore it will hold more sugar than regular tea. And now you breaking down electrolytes. Suppose you have a chemical, let's say SrSO4. It's a solid, and it's going to ionize. That means Sr2 plus, because the charge on strontium on your periodic table is 2 plus SO4 2 minus. It's not 4 SOs, because it's a polyatomic ion that has 1 of those things. If you had something like calcium nitrate, now you have 2 polyatomic ions, so that would fall apart to make calcium 2 plus and 2 NO3 groups 1 minus. And then you got the particle visualization part, which is on the homework. SrSO4 is 1 chunk, and it falls apart to make Sr2 plus SO4 2 minus. But don't forget, you don't need to plus sign. But don't forget that you need to hydrate it, so you have some waters pointing toward the positive and away from the negative. If you have this visualization, calcium nitrate falls apart, and you make a calcium ion with the water pointing towards, and not 1, but 2 nitrate ions in solution. That ends this lesson on solutions and electrolytes.